everyone. Warm welcome to science class. I hope all are doing well. By which process can seawater be purified? By which process can seawater be purified? The answer is distillation. Answer is distillation. The second question, which process is the opposite of evaporation? Which process is the opposite of evaporation? The answer is condensation. Condensation. Okay. With that, we'll start today's topic. Can matter change its states? Can matter change its state? We have discussed in the previous class about the physical characteristics of states of matter. Okay, so states of matter classified into three categories: solid, liquid and gas, and those physical properties. All those things we have discussed in the previous class. Today we are going to discuss about can matter change its state. Can matter change its states? Is of course matter can change its state. How can we change the state of matter? Listen properly. How can we change the state of matter? By changing the temperature, by changing the pressure. Okay, by changing the temperature or by changing the pressure. Okay. So can matter change its state? The answer is yes. Okay. The solid state, liquid state and gaseous state. So we have discussed in this three state in the previous class, and here you can observe solid state will converted into liquid state if we applied heat. Okay, by the process heat. Okay, by changing the temperature. And liquid will converted gaseous state by changing the temperature. So if we want to convert gases into liquid state, we have to undergo cool. We have to cool the substance. And liquid state, so solid, again cool. Okay, so this process we'll see in detail in this session. Okay, we all know from our observation that water can exist in three states of matter. We all know from observation that water can exist in three states. Is it or not? So solid as ice. For example, solid state. If we take ice, if we eat, ice becomes liquid. Again liquid. If we eat the water, it becomes vapor, gaseous states. Okay, if you cool the gaseous state, vapor, if you cool the vapor through the process condensation, so again it becomes liquid. So again if you cool the liquid, it becomes solid. Okay, so solid as a ice, liquid as a familiar water, and gas as water vapor. So we all known from our observation that water can exist in three states also. Okay, so next one I said that how can we change the state of matter? By changing the temperature and by changing the pressure. Okay, the first one is effect of change of temperature. First one is effect of change of temperature. On increasing the temperature of solids, the kinetic energy of the particles increases. If you increase temperature of solid, it increases what energy? Kinetic energy. So if you increase the solid temperature of solids, it also increases the kinetic energy. This point also we have discussed in the previous class. Increasing the temperature of solid increases kinetic energy, and this kinetic energy, due to increase in kinetic energy, the particles start vibrating with greater speed. So what happened? If you increase the solid temperature, automatically it increases the kinetic energy. Kinetic energy is nothing but what? The particles in motion. Motion. The simple word is motion. Okay. So due to increase in kinetic energy, if automatically the kinetic energy increases, the particles will start vibrating with greater speed. Okay. Next one is the energy supplied by heat overcomes the forces of attraction between the particles. Listen this point. The energy supplied by heat. So here heat is supplying energy. So automatically it overcomes the force of attraction between the particles. Because of energy supplied by heat, what happens? It overcomes the force of attraction between the particles. Okay. The particles leave their fixed position and start moving freely. So what happened? Already the particles in solid state, already we know that particles are arranged densely or closely. So now we have taken example if you start boiling the ice, start boiling. So what happened? on increasing the temperature of solid, increase kinetic energy. Automatically the first point is kinetic energy increases. Increasing the temperature of solid increases the kinetic energy. So as soon as the kinetic energy increases, what happens? It starts vibrating. So particles will start vibrating greater speed. So the ice slowly will started to vibrate. So the next point, what happens? So keep on the energy is supplying by whom? By heat. Automatically the what overcomes the force of attraction between the particles overcomes, and the particles will start move very freely. Okay. So the ice will started to melt and it started to move freely. Okay, a stage is reached when the solid melts and it is converted to liquid. So at a particular temperature, at a particular stage, what happened? The ice, solid started to convert it into liquid. Okay, melting point, the temperature at which a solid melts to become a liquid at the atmospheric pressure is called melting point. So melting point means what? We are discussing about solid converted into liquid. So at the temperature at which, the particular temperature will be there at which solid started to melt. Solid melts to, it becomes solid, becomes to liquid. That particular atmospheric pressure is known as melting point. Okay, so the melting point of solid is an indication of, so what is this melting point? So the melting point of solid is indication. What it is indication? Indication of the strength of the forces of attraction. Strength of the forces of attraction between its particles. So that particular melting point shows that how much the particles are attracted. So it shows that strength of the force of attraction between its particles. Okay, the melting point of ice is 273.16 Kelvin. Okay, so the melting point of ice is 273.16 Kelvin. And next one is fusion. The process of melting. The process of melting, that is change of solid state into liquid state. Here is important. Change of solid state into liquid state. Change of solid state into liquid state is known as fusion. So what is fusion? Change of solid state into liquid state. So that process is nothing but fusion. So now we have discussed effect of change of temperature. The first point, on increasing the temperature of solids, kinetic energy also increases. Due to increasing kinetic energy, what happens? The particles in the solid will start vibrate with greater speed. So after greater speed, what happens? The energy supplied by heat overcomes what? The force of attraction between the particles. And then the particles in the solid will start to move freely. At the particular stage is reached, the solid will started to become liquid. The next one is melting point. Melting point, the temperature at which solid melts to become a liquid at the atmospheric pressure is known as melting point. The melting point of ice is 273.16 Kelvin. And what is the melting point of, what do you mean by that? Melting point of ice, or else melting point of solid. So it is an indication of strength of the force of attraction between the particles. The next one is fusion. Fusion is nothing but change of solid state into liquid state. Okay. The next one is latent heat of fusion. Latent heat of fusion. So before we have discussed fusion. Fusion means change of solid state into liquid state. Here latent heat of fusion. Latent, this word indicates hidden. Latent means hidden. The amount of heat energy that is required to change 1 kilogram of solid into liquid. Here solid into liquid. This is important. The amount of heat energy that is required. The amount of heat energy that is required to change 1 kilogram of solid into liquid. Solid into liquid at atmospheric pressure at its melting point. So what? This is not boiling point, at its melting point is known as the latent heat of fusion. So latent heat of fusion means what? The amount of heat energy that is required to change 1 kilogram of solid into, here important is solid into liquid at atmospheric pressure and at its melting point. So melting point is known as the latent heat of fusion. Latent means hidden. Okay. So particles in water 0 degree Celsius have more energy as compared to particles in ice. So particles of water have more energy as compared to ice at the same temperature. Okay. And when we supply heat energy to water, particles start moving even faster. And compared to solid, in liquid there is enough space, so they can vibrate, they can move very fastly. And at a certain temperature, a point is reached when particles have enough energy to break free from the forces of attraction of each other. So what happened, already liquid we have enough free space. So at a certain temperature reach, so what happened, it starts to convert. So what, at this temperature the liquid start changing into gas. So liquid will start changing into gas. The next one is boiling point. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. So the temperature at which liquid will start boiling, not melting. Liquid starts boiling at a certain atmospheric pressure. The atmospheric pressure, that is known as boiling point. Okay. The next one is latent heat of vaporization. Latent heat of vaporization. We have discussed latent heat of fusion. So latent heat of fusion is nothing but the amount of heat energy is required to change 1 kilogram of solid into liquid. Here, total opposite, latent heat of vaporization is that heat energy required to change 1 kilogram of liquid to gas. Latent heat of fusion, solid into liquid. Latent heat of vaporization, liquid to gas at atmospheric pressure at its boiling point. Note this point, latent heat of vaporization, boiling point. Latent heat of fusion, which point? Melting point. Okay. So latent heat of vaporization is nothing but, latent heat of vaporization is the heat energy required to change 1 kilogram of liquid to gas at atmospheric pressure at its boiling point. Okay. And next one is sublimation, a change of state directly from solid state to gas without changing into liquid state is called sublimation. Sublimation, usually the state of matter will changes solid, liquid, then gas, and gas, liquid to solid. But in this case, what happened, directly it changes solid to gas state without passing liquid state. Is known as what? It is called as sublimation. Example, ammonium chloride. I hope all understood today's session. If you have any doubt, you can ask me, children. Thank you.